Greetings. I'm a distant student, Quinn Folks, bringing what may be good news, at least for some people, about math anxiety. Many people have math anxiety, yet can do the problems. They just choke with anticipation when it comes time to take a test. For people who have very, very high math anxiety, but don't do terribly, awfully badly when testing, there is something going on. And these researchers, Ian Lyons and Tion Bialik, seem to have figured it out. What the researchers did was they took a group of high math anxiety and a group of low math anxiety people, two separate groups, and they had used the short math anxiety rating scale for self-reporting. And before each task that they gave each person in each group, they offered a different visual cue. A colored shape was shown. One colored shape indicated that a math task was about to happen, and one colored shape, a different shape and a different color, indicated that a word task was about to happen. And they compared the results. While the low math anxiety and high math anxiety folks did not differ on the word task performances, which were equal in difficulty, by the way, to the math task performance or tasks. The high math anxiety folks performed more poorly on the math relative to the word tasks. Now that was expected. But what was interesting was that some of those high math anxiety people showed a much larger deficit in performance than others. And why was that? Given that the researchers had eliminated other factors, that was a bit of a puzzle. So what the researchers did was look at the relationship between math performance deficits and neural activity that occurred at the moment when the subjects were anticipating doing the math task. Not doing it, but before they did it, while they were thinking about it. Their intention was to see what parts of the brain were active during anticipation versus which were active during the task. And if there was a difference, they might be able to find a way to help students with a lot of anxiety about math perform better. So what they used were functional MRIs for the low math anxiety people as well as the high math anxiety people, and using both easy and harder math and word tasks for both groups. And here's what they observed. This is figure 2. You can see the areas as they light up inside the brain, here, 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 and here, and here, from the MRIs. And in the charts, you can see the red shaded area. To the left, you see a high number of eras by the HMAs, and then to the right, a lower number of eras by the HMAs. This is a scatter plot. And then the gray area is the LMAs, and they don't have a great deal of variation. The HMAs who activated this frontoparietal network, it's part of the brain, more for the math cue, but not for the word cue, also showed nearly complete elimination of their math deficits, 2.9% on average, whereas those who did not show this activation had much greater deficits, 21.8% on average. Table 1 summarizes region details for regions and regression diagnostics that you just saw in figure 2. The relationship between cue activity in the brain and math deficits remained highly consistent even when controlling for the ratings of math anxiety with SMARS. There was no positive correlation between math anxiety and math capability. Table 2 shows the HMA correlation results for each cue separately. The LMAs weren't considered because they have no Q performance relationships. There was a correlation between certain areas of the brain and math Q activity and other areas of the brain and word Q activity. Well, what Table 2 tells us is that HMAs who activated this frontoparietal network more for the math cue but not for the word cue also showed complete elimination of their math deficits, 2.9% on average, whereas those who did not show this activation had much greater deficits, 21.8% on average. Presumably, then, there should be some neural regions whose activities during actual math performance directly mediates the relationship. Here's a bit of anatomy for you. What the researchers labeled inferior frontal junction wasn't understood by the neurologist with whom I spoke, so there was probably a typo. I think what they meant was the left frontal superior gyrus. At any rate, they are noted here and just showing you what they look like in a different type of model from a different viewpoint. And here is just a reminder of what the frontal here and the parietal here lobes do functionally. What researchers checked next was the neural activity while a math task was being done, in hopes of explaining the relationships between the frontal parietal cue activity and the HMA's math deficits. Both the right caudate and the left hippocampus were included as simultaneous mediators to examine their combined mediating effect. These regions are highly correlated with each other. Note, the left mid-posterior hippocampus in particular appears to be central to maintaining information in one's episodic working memory buffer. Together, these regions are thought to play a central role in integrating higher cognitive control of goal-driven actions, i.e., through the selection of appropriate action schemas with motivational and reward context. The researchers saw that regulating negative emotions is a key to reducing anxiety for math anxiety individuals. This doesn't work for low math anxiety people because they don't have a negative emotional response while anticipating doing math tasks that require reworking to lower their error rates. These areas, the right caudate and the left hippocampus, seem to assist with active, episodic, and semantic memory retrieval. And the data researchers found in this study supports those findings. And the other thing to think about is that the caudate here and the nucleus accumbens and the hippocampus all activate while math problems are being solved. So anatomically, the caudate head receives primarily glutamatergic inputs from the prefrontal areas as well as dopaminergic inputs from the nucleus accumbens and ventral midbrain regions. Now this is interesting because dopamine levels in the dorsal caudate have also been shown to correlate with delay activity, i.e., while holding information in the mind in the left IFJ during a Sternberg delayed recognition working memory task. So one way to interpret the data is that HMAs who show the smallest math deficits do so because they're able to they're able to dynamically reorganize their approach to doing math. The side note about the nucleus accumbens is that it may be responsible for motivating behavior and regulating effortful functioning. It takes that kind of effort to overcome the anxiety about math tasks while actually doing a math task when one is a high math anxious type. And the moral is, just keep swimming. It's not a secret. Positive thinking works. Having more cognitive control helps to reduce math anxiety before a math test or task, and to mediate it when it does strike. Taxes might include, but it's definitely not limited to, cognitive behavior therapy, mediation, visualization, positive self-talk, coaching. And one of the points to remember about all of this for parents, friends, and teachers who provide moral support to people with high math anxiety: more drills and studying for this particular situation won't help. Educational practices should not go to more expensive to provide more coursework, but rather work on teaching students how to marshal cognitive control and to help reduce math anxiety before it adversely affects performance. And one final note: math anxiety is different from typical anxiety. It doesn't show up where you'd expect it to, which would be in the amygdala, the hypothalamus, and the insula. Also note that brain areas affected are not the same ones related to doing calculations. So to sum up, math anxiety is a totally different animal, and it's tameable for many, so there's one less reason to suffer. Here are my sources. The paper was Mathematics Anxiety, Separating the Math from the Anxiety, and it was by Sian Bieluk and Ian Lyons. Sian is the same person who wrote the book Choke, What the Secrets of the Brain Reveal About Getting It Right When You Have to, and I think it's a fabulous book.